Hi Caleb, this is Bhagya. So here is my fourth assignment regarding heaps. So let's start from the basics to upwards. So here I have created a class binary tree node with index with the properties index, data, parent, left, right, and using that as a root for my binary tree here. And there is a count property to keep track of how many elements are added, and these are few helper functions. And I have added get most recently added node. This logic is based on the algorithm you explained in the class, getting the binary value of the count and removing the first digit and then looping through the rest of them with 1 to the right with 0 to the left. In to get the most recently added value. Here with insert, I'm adding 1 to the count to get the last position to add an element. So same logic, right, left, and then adding the node and setting the node parent value. So, and increasing the count value. And this binary tree is used as the backup data structure for heap. So here I declared is empty method to track if there are no elements, and there is a swap helper function which swaps the data of when we want to like change the order, add function, remove function, up heapify function, down heapify function. And the highest level data structure is a priority queue. Here I'm using the heap as a property of the priority queue and instantiating the heap in the constructor. And there is a length method to check the count, and there is an enqueue method to add the item, dequeue method to remove the item, peek to look at the root value of the item. So let's go ahead and run the application. I'm sorry, I'm suffering from cold. So okay, here I'm using few helper functions to create the key value pairs and blah blah blah. So here I created the list of the numbers you have given in the assignment, just like you explained in the class. I'm creating a class of priority queue, and then enqueuing underlying is heap.add. This inserts the data at the last position and increments the counter, and then up heapify. So just like it is explained in the class, as long as a parent is not null, comparing the data, which is key here. The comparison is with the key, not the value, and then swapping them and setting the value of node to the node dot parent, value of node from node dot parent, and then continuing the loop. And after adding all the list of items, there are 3 DQs called on the priority queue. So DQ and write to console to show what element is present at the priority. So let's go and take a look at the DQ. DQ underlying is heap.remove. If there are empty, it throws an expression exception saying no elements found, and we want to get the data at the root. If count is equal to 1, we are setting the root to null so that there are no more elements, and setting the count to 0, which is minus minus, and then returning the result. Else getting the most recently added node using the binary logic, and then swapping, setting the root parent to null, and deleting the most recent node, disconnecting from these node from the tree, and then decreasing the count and then down heap e5. So starting with the root, as long as there is no children, it continues in the loop with getting the element down and down in the tree. So let's look at the result. So 3 times DQ. Priority at 4 is 4, priority at 5 is 5, priority at 6 is 6. Let's perform an action. Yes, NQ1, 1, and priority at 1 is 1. So let's do it again. DQ, priority at 1 is 1. DQ, priority, next number is 7. So that is how it goes. Thank you.